As we have seen, one way of entering the design specifications is to draw the circuit schematics manually, which can be tedious for larger and more complex ICs. The solution is to write a source code containing all logic operations for the desired functionality. The special programming language used for this purpose is called HDL. HDLs are different from the well-known software programming languages like C, C++, Fortran, etc. In a sense that HDLs can model the parallelism of the actual hardware, whereas the software programming languages are of sequential nature. We use the term RTL description or the register transfer level description, which basically means that the circuit specifications written in HDL can be directly converted into actual hardware registers with interconnects. This RTL description can later be used for logic synthesis and functional verification. There are many HDLs in use, like HDL, Verilog, System Verilog, etc. But among them, Verilog is a popular HDL because of its simplicity and design portability. It has a syntax like C, and the RTL description written in Verilog can be used for synthesis and verification by all Cat tool providers like Ultra Ultralinks, which ensures the design portability. For the remaining slides of this presentation, I'd like to introduce you to the basic structures of Verilog. The basic building blocks of Verilog are the modules and the ports associated with them. On the surface level, the Verilog module can be thought of as a black box that encapsulates the desired logic operations. Ports are basically the means for communicating with other modules. There should be at least input and output ports connected to a module, but sometimes we also notice the bidirectional ports, which are called the in-out ports. Here we can see a Verilog module declaration. Starts with the keyword module, followed by user-specified module name and a list of all necessary ports. Module declaration must end with the end module keyword, and the logic operations are written in this middle region in Verilog. In this slide, we will observe how logic synthesis is performed by Verilog compiler line by line. First, we need to declare the module along with the ports. Keep in mind that the module declaration must end with the end module keyword. At the right-hand side, we can see that these two lines of code will generate a Verilog module with the name and the list of the ports as specified here. Next, we specify the directions of the ports, which are synthesized likewise. So this is how a Verilog module declaration will be synthesized.